All right, cool. Yeah, we have my daughter's dog joining us today, as well as my sister-in-law's dog also joining us today. So she's the black one that was on the floor earlier that now I'm completely covering up. So only those here early enough actually know that she's there. How's everybody doing today? Purplish and meat, what's up? Secret dog, absolutely. Hope you guys are well. So I was supposed to start Cock, and I just wasn't ready today. I didn't know if I was going to get to stream today. With the holiday and everything, there was just, you know, quite a few unknowns. So kind of just left it at that. Okay. Looks okay. Everything's there. Music's on. Not really dropping frames. I think we're okay. Cool. Some awesome and HTML canvas and Rust. That sounds cool. I did a lot of canvas work when I used to be in front end. A lot. And we didn't even use React or anything. It was interesting. I can't remember the name of the library we ended up using. It's been a long time. 7-8 years. Nice. Hold on one second. There was something I was just thinking of. Oh yeah, starting soon is still on. Okay, we'll take that off. Okay, so we got hello world, and we can move hello world around. And we've got a ball in here. Very cool. I like it. Yeah. Yeah, we developed, like, I worked for a glass company, not even joking. But we were developing an entire shower design suite. I mean, we did. We built it, and it's in use, but you know, I'm not at that company anymore. And so we drew everything on canvas, and it allowed people to like design these showers that were mathematically accurate, and then like it would actually send it in gosh, I forgot the extension, but the actual fabrication instructions to the machine that they used to cut the glass. So pretty interesting work in a way, like both like totally random and boring, and also like kind of interesting, at least for a while. It's cool though. Nice to meet. Very cool. Hey, Merrick. Yeah. OCaml's okay. Yeah. It's different than Haskell for sure, and kind of getting used to that, getting used to the ways that it's different. I wasn't really supposed to do an OCaml day 3, but I wasn't quite ready to start the dependently typed languages. And just with some personal stuff going on, I'll actually have a lot more time to stream this weekend than usual. My family will be out of town. Error prone Victor, hey, how's it going? Welcome in. Yeah, we're on week 3. Yeah, if you've only been tuning into YouTube, I'm only somewhat, I think I finished posting day 2 of Haskell. So we actually are not, YouTube's almost caught up. Hey Scottish, what's up? Yeah, so we're into OCaml right now. So we're getting there. Thanks for the chat, Victor. Yeah, so let's see. What was I saying? Oh yeah, so my family's gonna be out of town. I'll be out all day Friday driving and stuff. For some reason, you're live streaming you gaming on Xbox, like on Twitch or just on Discord or something. So yeah, I'll have a bunch of time this weekend to stream, so we'll have plenty of time to go over our dependently typed languages, Kok, Agda, and Idris. So yeah, cool. I didn't know you streamed at all. Is this like the first time you've actually streamed something? Very nice. Yeah, cool. Now you got that sweet follow action, Scottish. You're playing Overwatch? Nice. Yeah, we might even do a game stream this weekend. We'll see what happens. I'll have some time on my hands. I mean, I have some other things to do, of course, but might actually have some time to play some games. That might be fun. All right, sick. I think we're ready to get ready. We're ready to get ready. We're ready to get started. I'm just doing random stuff. Oh man. Okay, cool. Yeah, only written low-level languages, so nice with a tour of the bigger picture. Yeah, that's cool. So you've mostly written probably things in here. Possibly not this one, considering it's fairly new. But and then probably some Rust. Yeah. Very cool. Yeah, yeah, I have quite a bit of Rust stuff that I've done. We'll probably get back to it. So yeah, let's get started. I'll talk about the tour in case there's anyone else new here, and kind of what we're doing, and then we'll get into working with some OCaml stuff. I'm not exactly sure what we're doing. This is kind of just a bonus stream at the end of the day, so I didn't like really have something deeply in mind. We don't have error handling in our API that we built in OCaml yesterday, I guess it was. So we might as well fix that and do that, but we'll see what happens. So far, we're doing 12 languages in 4 weeks. We've done 9. Technically, we finished OCaml as far as my normal schedule goes, but we're just gonna do an extra day. Might do some work on dependently typed today, just like learning some things about proof theorems, stuff like that. So we've done C, C++, Zig, Scheme, Common Lisp, Racket, Standard ML, Haskell, and OCaml so far. We've written FizzBuzz in every single one of those languages. We've written a working web API. I believe it's working in every single one of those languages besides Standard ML, because I just didn't feel like dealing with the dependency issues. So instead we did an AOC challenge in Standard ML, and that's kind of what we've done so far. I chose these languages because I haven't really written any of these. I don't have a CS degree. I've been in the industry for 10 years, mostly working with, professional anyway, mostly working with Java, and for the first 5 years, JavaScript and TypeScript front end, and then going into Clojure about 5 years ago, and that's my full-time job, is writing Clojure just as a back end. I know. Ryan W was pretty bummed about that, Nightshade. Thanks for that, by the way. Thanks for making sure that you know my new my new internet friend Ryan Winchester was mad at me for not including Elixir or Erlang on this list. My new internet friend, which means I joined his stream one time and chatted with him for a little bit. Yeah, he 100% hates me. That's fair. Me too. Me too. Yeah. So the only language of these 12 that I've written more than a dozen lines of code in is Haskell, and that was a long time ago. I hadn't touched it for 4 years until we did it this week. That was, let's see, that was Sunday, right? Yeah. We did Friday, Sunday Haskell, Monday, Tuesday OCaml, extra OCaml stream today, and we'll get into dependently typed on Saturday. Since I'll be driving a lot on Friday, I'm not going to stream. Just some last minute travel that the family is doing, but I'm staying home, thankfully. I would prefer to stay home. I like staying home. It's cozy here. I've got my boxed television behind me. I mean, it's just really nice and cozy. Yeah, no streaming from the car. Yeah. Okay. So where do we leave off with OCaml? Let's just do a quick review. We wrote FizzBuzz day 1. We learned the basics of the language. Here's a little match syntax of OCaml with I guess they still call them guards, right? Like a guarded match, I believe is how you would say this. And then we went into an actual project. That project is in our Hello World directory. One moment here. There we go. So let's see. So most of the languages follow this same thing. The build's gonna screw it up, but let's see. I'm not very good at tree sometimes. I know I can do levels. Isn't it something like this? No? That's okay. I don't remember. It doesn't matter. The point is we have a bin directory. This is what Dune init creates with a main.ml. Then we have a lib directory that has a hello world.ml. And we just played with the hello world MLI. It's not actually required. Just to demonstrate a few things about how OCaml modules work. Yeah. Guards are good. Guards are good. Okay. Sweet. So that's pretty good. Let's just look at where we are in our Hello World API. So our entry point is our main. No surprise there. We're basically starting here with dream.run, and that's just taking the routes that we've defined here. This is just method, route, handler, or endpoint handler. And these are all of our handlers. We're making some calls. Anytime you see hello_world here, that's calling out to our library file that's called helloworld.ml in our lib directory. So that's going to our library module called hello world, and all of these are working. There's a couple things we didn't do. We didn't do, well, first of all, we don't have any error handling, right? So we probably want to do some error handling. 404s are handled for us because the router is pretty functional and nice. But there's some error handling specifically around the goodbye endpoint, where we could easily have a bad data that we'd want to do a 400 on. And then there's also, what's the other thing? Oh yeah, we wanted plain text responses, right? Text/plain content type for both hello and goodbye. Hello name has a JSON. Hey Cherry Heart. I am using eglot for OCaml LSP. Yeah, so I Yeah, just trust user input. What could go wrong in Disney is a 500 error. So we demonstrated our 500 error yesterday. I think my web server is still running. And if we go up, I don't want to have to type these again. Where are they? There it is. Okay. Well, at least do this one. Okay, so there's it working. But if we say misspell, we just get a 500. Obviously, that's not the most ideal situation. And then, oh, that's the other thing I want to do is all my other APIs use port 3000, so we might as well do that. That way it's all the same. So kind of just little things, and then we'll see where we get from there. So that's the current state of the API. But yeah, Cherry Heart, I can't remember if I answered the question, but yeah, I use Eagle-Eye instead of LSP mode. It just works better for me. I tried LSP mode and I had a lot of performance issues. I'm not saying that's necessarily with LSP mode. It's probably more to do with my config and the fact that I really need to recompile Emacs, but here we are, you know. I still haven't done that. Maybe I'll do that this weekend. Maybe we'll do a making Emacs faster stream. Who knows? We'll see what happens. Okay. Let's see. Oh yeah, I need to send a message real quick. I'll have to take a quick break at 1/4 till. Coming up here in about 35 minutes to help somebody coming over to do some things. How about that for vagueness? Streaming in Office. You can let yourself in and get mail key. Then when you come back, knock on office door. Okay, nice. Cool. So let's see what dream.run takes. I'm guessing dream.run probably takes a port. Okay. So it takes a port, but this is when we get into like named arguments, and I feel like I've seen OCamlers do this, something like this, but I don't know if that's correct. It probably isn't. So let's find out. So let's look at some dream examples, see where we're at. Let's see. We want to look at dream.run. What did I do? Probably a lot of runs. 37. We can deal with that. Okay. Any great examples here? Okay. We're running out of documentation. Okay, let's look at dream.run here, maybe, because I don't remember actually getting to that. I'm probably really close to it now that I see where it is. Yeah, it's fine. We clicked over to it. Okay, so port is the port to listen on, defaults to 8080. So is it just that I'm supposed to use a colon and not a equal sign? That could be it. Yeah, I think that's it. name parameter to a function in OCaml. Tilde name colon value. All right, let's see what happens. Unbound record field greeting. Oh yeah, this was I did that on purpose to show hiding modules. I remember that now. Nice. So now we're on 3000. So we just need to change all this stuff to be 3000. Sick. Okay. So we finished this. Let's see what else we have. Error handling and goodbye. And then text plain content type. Okay. Doesn't really matter which one we start with. I guess we'll do error handling and goodbye. Yeah, we'll start with text plain. Okay. So for this, I know I'm going to need to use dream.response and then set my own content type, probably using the headers function. So let's see what happens here. Code status. Okay. Status code headers. 200 by default. And it just takes, okay. Okay. Or use a wrapper like dream.html. Okay. Cool. Okay, so here instead of dream.html, we have to say dream.response. Now, I'm forgetting what dream.addHeader actually. Oh, I see. We can just provide a tuple. Isn't that what that is? String star string of. Oh no, headers is string no string. Okay, let's see. Oh right, a list of tuples and a string and a response. Okay. Let's see. So we could probably do this without. Oh right, the string is just the response. Duh. Okay. So then we might be able to get away with not anything more complicated than just defining this. We'll see what happens. Let me double check the type of a tuple. I want to say comma is for tuples. Is that right? Yeah, that is tuple. Okay, cool. All right, so then in that case, we should be able to just say content type. And then say text/plain. But let's see if they're mad about this for some reason. This expression has type A times B, but an expression was expected of type string list. Oh, right, this isn't a list. Okay, you're right about that. How about now? You happy with this? This might do it. I will say that name parameters are pretty freaking great in a lot of ways. The expression has type dream.request. Okay, to dream.response, but an expression was expected of type dream.handler equals dream.request to dream.response. Okay. So then, not what I was expecting. Let me just think about this. We have dream.response. We're passing headers. We're passing string. which is hello world.world, and then it should return a response. And what's this considered? String list. Okay. Which is exactly what they were looking for. And this is a string. Okay. So maybe dream.response just does something differently than dream.html does. Creates a new, oh, wait. Same as dream.respond, but the new response is wrapped in a promise. Maybe I want dream.respond instead. Let's see. Ah, yeah, dream.html is the same as dream.respond. Okay, so instead of dream.response, we actually want dream.respond. And then it's weird that the LSP said I was fine, which kind of makes me think that my LSP is not working again and I have to reconnect it. All right. So let's do this, do a -v, and we have a text plain content type. Beautiful. So then all we have to do is do the same thing here. And we're just going to say headers. So we could define these somewhere else. I guess we can do that real quick, right? Might as well. We'll just say let text plain plain equals, and we'll grab this. Where else was I going to put it? 14. Okay. A little bit nicer. Whoops. Might help if I restarted. Okay. That looks great. And just need to change our port on our goodbye. Okay, right, that's the 500 example. Let's see if this one works. Okay, cool. So we finished our content type, so now we just have error handling, and then we're done, basically, with this little toy example. Okay, so this is where I'm a little bit surprised with OCaml, in that when I'm in hello world.getName, basically what I should be doing is, instead of returning a string like it is right now, so we can look at this. Yeah, so getName is string to string. We actually want getName to probably be a result string error. So that's probably where I want a result instead of a string, and then I can match on that result in my main. Very similar to how we would do this in Rust. So let's just define our type signature. That way maybe we can get some help. Oh yeah, that's not how you do it. Haskell moment. Okay, let's go to our MLI file and define our type signature here. I actually don't know how the result type works exactly, but let's look at this. Okay, result string, right? Okay. Okay, error value, get okay, get error. Okay. So basically, let me think about this. Where is it going to be having a hard time? It could be in either of these. Like if the string isn't actually JSON, this could actually give me an error. And then if the string isn't a valid named, since I'm just like serializing this into the named data type, that could give me an error. And that brings us to here. Okay, so I know that I would say this, but this could be the wrong way to do it. OCaml unbound value. Okay, is it result.ok? Yeah, that's what it is. Okay, so we have a result.ok named name, and that should bring us where we need to be in terms of our MLI here. And then I'm kind of surprised that YoJSON doesn't have like where I would have kind of expected that they would return this as a result. Like that's the way that we would do it with a Rust JSON library. But for some reason it doesn't do that, and that's kind of annoying in my opinion. Like it just returns this yojson.safe.t, but like how am I supposed to know that there's an error here? Because errors are values, right? Like is there some sort of like weird part of JSON, I mean of OCaml, where you can just like throw an exception instead? I don't understand. Maybe I just don't understand error handling in OCaml. I was assuming that it was just going to be done the way that Rust does it, because Rust kind of like stole the idea of the result type from OCaml, but come on, OCamlers, what's up? I know I'm streaming earlier than usual, but like what are you guys doing? What are you guys doing with this? All right. Builds an error handler from a template. This is all in Dream. Okay, well we do need to know about how to actually do this whole thing, but we'll see. I mean, actually realistically, we're just going to use respond and say 400 if we have that bad error, right? Now, you know, I actually can do that part right now, even though this isn't working the way that it is, but that's okay. Let's just go into main.ml. I'm going to reconnect my LSP. I'm like certain that it's broken at this point. Okay. All right, so we have let name equals hello world.getNameBody, and we actually just want to match on this. So I think what we want to do is say let name match hello world.getNameBody. Okay, and I'm forgetting match syntax, but we have that. One moment here in our FizzBuzz, so we can just look at it. Match X with, that's the part I couldn't remember. It's match with, okay? And then this is just going to be, okay. We'll just say N. And I want to say it's a skinny arrow. Is that right? Yeah, skinny arrow, just like, come on. Yeah, I know. Get back to me. Trying to use Vim bindings to switch buffers, and it's annoying. All right. And then what do they call it for? I don't remember what they call it in result right now. For the none. Do they just call it none? No, they call it error. Okay. Oh yeah, so this wouldn't work, right? How would I actually do this? I guess how I would do this is this would be my main thing here. And then I would take this up here and just go here. And then if that doesn't work, we'd say dream.respond and what is it called? Status. Status is 400. And we don't really need, I guess it did require a string, right? So we'll just say bad request. We could, yeah, we might as well put in the data. Okay. Of body. Which means we then need our application operator like that. Okay. So obviously this is not the right way to do it. So let's see what pattern matching on a result looks like. Well, that's GPT. It's been a while. It's been a while, and you know, GPT's been through a lot this week. So we should just try to help it out a little bit. And OCaml. Oh, it's okay of. Okay, and then it's capitalized. Let me see. Okay of, error of. Okay. If y equals 0, then error division by 0, else okay. That's interesting. That's not how I thought that this worked, but maybe that is the right way to do it. Okay. We'll try it. I don't know if GPT is just like... This pattern matches values of type AB result, but a pattern was expected which matches values of type string. Okay. Interesting. Let's go back here. And let's pretend that this is not how you do this. So this actually works. Okay takes A and turns it into a result of AB. Okay. Huh. Alright. So maybe I just have my type actually wrong. Could be the case. To string a result. Okay. So I probably just didn't know how to write that. So let's go to MLI. And string, comma, a, comma, result. Is that what it was? Mm-hmm. String, a, result. Okay, got it. Interesting. Okay, cool. That looks fine. 1 second. All right. Okay, so there we go. We figured out how result types work a little bit better. What the type looks like versus the constructors, basically. So yeah, I guess that makes sense. Let's see where we're at. That's where we just were. Let's go to our main. Okay, so now we're back here, and it's pretty sure that I'm wrong about something. The constructor error expects 1 arguments, but is applied to 0 arguments. Okay, so if I say E, like that. So why is the pattern expected which matches types of value string when I've actually changed it? Oh, that's weird. It didn't actually update here. Huh. Do we have to like run a stack build? I don't understand. I mean, a stack. A Dune build. Okay. This expression is type int, but an expression was expected of type dream.status. Oh, okay. So we actually have to use their whole dream.status thing. Well, stack is happy with it, so I don't know what the LSP is. Oh my god, I said stack again. Dune is happy with it, but I don't know what the LSP is freaking out about. Like, they're right about this, but they seem to be wrong about this. And they seem to still think... Nope, they updated finally. But then what's this about? Yeah, I still don't get what they're... Let's just try making an edit, and seeing if it clears that error. It does. Okay. It just wasn't updated. Okay, so now we just need a dream.status. I'm gonna guess that dream.status is an actual thing that we can use. No. Okay. So how do we get a dream.status? Let's look at the dream docs. Where were they? Okay, status codes. Type successful. The most common is 200. Okay, sure. Oh, I see. So then... Oh, this is interesting. Wrong chat, Dylan. Wrong chat. We're fitting in an extra OCaml stream because my family's going on a trip this weekend without me. I mean, typical. No, I'm just kidding. I didn't want to go. So I'm staying home. So they're gonna go have fun. I'm gonna stay home, do some extra streaming. So we'll have some extra time. So this is it's just a fluke. It's not anything about me liking OCaml. It's just a fluke. All right. You did come at a good time though, because I mean, I see the status codes. I see type successful, and then I see that it's defined this with little ticks. But like, how's that work? Like, do I say dream dot client error Okay. And then do I get something? No. This is just a bunch of... What is all this stuff? This isn't what I want. Oh, really? Okay. So I don't have to like do all of that. I can just say bad. Oh my god. I'm getting there. Bad. What is it? Request? Yeah. Okay. This seems fine. The variants with a tick are polymorphic variants, aka extendable variants. They don't need to be namespace. So then I'm guessing you can't have collisions. Like if there's a collision with a polymorphic variant, then you'll get like a compiler error or something. Or do they just try to infer it based on the type that I'm trying to pass it into? Like since status takes a dream.status, maybe it just knows. A collision would just join them as the type. Oh, okay. Okay. Uh-huh. All right. Yeah, I get it. Okay. What did I do wrong? Oh, unused variable. Yeah, I don't really care what the actual error is. Okay, route's still working as expected. I'm pretty sure this isn't gonna work. Yeah. So this is the part that I don't understand. But before chat just explains everything to me, unless you have particular resources, I'd rather read about it. So my match works just fine. I'm not actually worried that the match is wrong. I believe I know what's wrong is in my lib, both of these could return an error or have an error, but they don't return result types, which is how I'd have expected it coming from Rust. And so, like, you know, we have our question mark operator, but that only works if it actually returns a result type. That is in Rust. I know there's a similar thing in OCaml, I just don't remember what it is, but I don't know if it's actually going to work here. I don't think it did. Does it? Nope. Safe.t to named. Olavo Stores. Hey, what's up? Thanks for joining. Yeah, we're doing a little bit of OCaml. Okay, so yeah, so named of YoJSON just returns a named from a YoJSON safe.t. All of yours return results. Bummer. Okay, let's see if they have an example of how to handle this in the dream example with JSON, but most of the time they're just going to give you happy path. Happy path BS. Yeah, look at this. Look at this happy path BS. Huh. I'm looking at PPX YoJSON conv, but maybe I actually just need to look at the YoJSON docs themselves. I don't know. Okay. 1 second. Right, that's what generates named of your JSON, right? But then, like, so can these guys, like, is there such thing as like throwing errors in OCaml? Like, I was assuming that there isn't. So I don't understand. You can, yeah, okay. So this is just like thrown. Annoying. Okay, tuples and units, records. Let's keep going. Maybe we can say defaults, allowing extra variants, well-typed witch. Hey, how's it going? That can throw with exc. That makes sense. Yeah, we're doing some OCaml today. Day 3 of OCaml. We've had some fun with a bunch of languages this month. We did SML and Haskell, and now OCaml. We did a bunch of other things before that, but I don't think they're well typed, so you might not be as into those. yeah, Haskell was fun. I wrote a bunch, so I'll just do this since I don't know if other people have joined too. But Twitch viewer stats are bogus. They're pretty much always wrong. So this is what we did. We're down here. We mostly just did 2 days, but I wasn't quite ready to start this yet. So we're gonna start this weekend and have a bunch of fun with super nerdy things that are probably way over my head, but we'll get there. So yeah, of all these 12 languages, I've only written Haskell before, at least more than a dozen lines in. And yeah, language tourism for sure. And it was like 4 years at least since I'd really written Haskell. So I do Clojure full time. I'm in this category full time. So we don't think about all of those type things every day. But I do love the HM. I love the HM. Okay, where were we? We were looking at ppx.json docs. Okay, let's just try searching for errors, maybe? No? Well, it might be helpful if I didn't write rtot when I was searching for errors. You're learning C. Cool. Nothing about errors. Exceptions. You're not handling exceptions in YoJSON derivier. Du rivier. Okay. So I guess it does raise. Is raising what they call throwing in OCaml? You raise an exception. All right. Senor Dev. Yeah, okay. Good deal. All right, so I guess we need to wrap things in try with as. Yeah, I'm very confused. I mean, we could convert this to the other one because I definitely like results, but oh well. At least I'm going to return a result from this. So I'm going to take their less nice API and we'll wrap it with a little try. And oh well, at least that's something I'm not totally used to. Yeah, I assumed as much. Okay, so if I say try, let's see, let's just look up docs. That way I don't get this completely wrong. It's probably not going to be learn. Okay, nope. I'll probably get this wrong if I... Is there like a nice searchable... Where's searchable documentation? I actually don't even know. I did this whole thing without searchable documentation so far. Pattern matching, dealing with errors. This is probably the best. The bar. Are you saying that I should search using the search bar? Well, Scottish, thank you. I hope you had a fun game time. Okay, let's see. Exceptions are raised using the yeah. Exceptions are raised using the raise function. Okay. Try with. Okay, so try this with failure, then do that. Okay. So then I guess I would just wrap this entire thing in a try. Like, can I just do this? And then I would say with failure underscore error. I guess I can return it even though I don't actually care. Failure F. Failures are F's apparently. Error F. Sure. Does that look okay? Nope. Let's see what it says. It's probably the string is not compatible with type A. Type string is not compatible with type A. Okay. And that's because I changed that here. Okay, because now that... So obviously this failure is an F. I mean, this failure is an F. This thing is a string. Okay. So now I just have to change it to string. That's fine. We can do that. Okay. Why do I have an extra line up there? That's annoying. Nice. Let's see what we get. We still got a 500. I did something wrong. Huh. Okay, that was not expected. Raise failure sorry else n. Could they be raising something else? Dream.http error. Huh. Okay. It's possible to define exceptions. Sure. It'd be the ppxlib raising. Right. I get that part. Hold on, pup. Hold on, sorry. Let me try muting. All right, I'll be back in like 3 minutes. Give me a second. Still muted. Okay, there we go. All right. Yeah, I mean, I just wanted to see what the whole try with was like now that I knew that was the issue here. But maybe that's what I should do. Okay. Yeah, all right. Let's just change it. That's fine. We can change that. And then we'll go from there. So in libdune, we're going to change this to ppx deriving JSON, and then we just need to actually add it to our Dune project. All right. So let's try it this way. Dune 2 coming next year, huh? Yeah, the whole roadmap thing. Yeah. Oh, it's ppx.json.runtime. Okay. Let me see. You sent it to me the other day. Oh yeah, I have your thing open somewhere. Do. Am I reading a book? I don't think so. No, I've been doing a tour of languages. OCaml's just one of them. So we're on day 3 of OCaml. 12 languages, yeah. No, there is a book called 7 Languages in 7 Weeks. No, I just made this up. I just made it up. ppx deriving.make, ppx deriving.show, ppx deriving JSON. Oh, okay. And then in libraries, I also need it. That's what you're saying. Okay. So then it's probably, let's see. Right. So then here we have to say libraries here. Okay. Yeah. So then we can install, and then we have to change it in our is it really this, or did I have it right the first time? Oh, that's just version. Okay. So I do just need to do that. OPAM was just taking its usual sweet time. Okay, so then in Dune project, should I be changing this to .runtime, or do I need both? I guess I can just look at your Dune project. It's just a package inside the lib. Oh, okay, that makes sense. It's all right. I can use GitHub myself, Dylan. I can do it. I can really, really do it. Okay. ppx deriving JSON. Cool. All right. So that's good. We just had to update our libdune to be that. Yeah, planning on doing AOC. We're probably going to do like a language roulette. And so it's not going to include all 12 languages, but let's say yes so we can get this on the road. But I think we'll probably do Zig. I think I'm going to leave out C and C++. We'll probably do Zig. Common Lisp. I don't want it to be too many because then I'm going to have to think about syntax all the time. So it's probably going to be Zig, Common Lisp, maybe another Lisp. No, I'm gonna do Clojure. That's right. That's my day job lane. So we'll do Zig, Common Lisp, Clojure, and then we'll do all the MLs because I like MLs a lot. So we'll do by all the MLs I mean on this list, you know, SML, Haskell, and OCaml, and then we'll see if any of these make it on the list. I mean, definitely not Coq, but like maybe Idris. We'll see. We'll see how it feels when we're actually doing them. Yeah, I do Clojure at work. Yeah. Clojure. So it just depends on how active chat is, like on whether we do a poll for the language or whether we just like create like a generator, a simple script that will tell us what language we're going to use. Python. This is why, yeah, no, it would be a poll with only my options on it, and Python would not be one of those options. Yeah, we did Haskell earlier this week actually. So we did 2 days of Haskell. I wrote a bunch of Haskell probably 5 or 6 years ago, Mad Flash, and just kind of got back to it recently during this tour of languages, the exploratory language tour. Yeah, thanks for the follow, Mad Flash. I appreciate it. We'll do more Haskell. I love Haskell. It is still probably, like, I used to say it was my favorite language. I know I didn't write it for 4 years, and like getting into Haskell again, it warms my heart. It's just a really, really nice language. Hey, Awar, I don't remember what ATS is. Is it a lang? I'm guessing. Statically typed programming languages. Okay. Oh, C plus Coq on steroids. Nice. So it's like, oh yeah, it's pretty wild. I'm sure I've heard of it, but I just never stuck. So many things out there. That's really cool. I'll leave that one open. All right, OPAM. I can't say you're the fastest downloader and installer I've ever used, but you know, we wrote Rust for several months on stream, so waiting a long time is not something that's foreign to us. Yeah, exactly, Matt Flash. Yeah. It was okay when I did just data structures that I was implementing myself. Yeah, I need to download more RAM. When I was doing this series in Rust, it wasn't so bad because, yeah, I wish. It wasn't so bad because I didn't use any external libraries. So 64 gigs apparently isn't enough. Oh my God. Unbelievable. That is OBS though. It's like amazing FOSS, right? But like, wow, it eats up some RAM. OBS written in Electron. All right. No, if it was written in Electron, it would take up that much RAM just to load the UI, and the UI wouldn't actually do anything, but it would just be a UI. All right, so we've got PPX deriving JSON installed. Let's see. I've done a few. I just keep writing stack. See, been writing Haskell too recently. I keep wanting to do stack. All right, so let's just pretend like we can do this. Oh yeah. If I actually remembered how the commands work. Okay, right. I don't have that anymore. That's fine. Yeah, I don't mind leak code. I don't love it either. It's like, I don't know. Okay, so I'm guessing I'm gonna need something. Oh yeah, and my MLI is all gonna be wrong. I'm thinking I'll just remove my MLI for now. I don't know. It doesn't really matter. We'll just go through all the errors of transitioning. It's interesting enough. Hey, this library sucked, so we're gonna have to use something else. Okay, so what is this called? PPX deriving yo JSON. Looks good. Looks good. Require PPX deriving yo JSON. Okay. And deriving yo JSON.safe.t. I feel like this isn't telling me what I need to put at the top of my file, but nothing? So then I'm only getting, maybe I'm just getting these errors because of my MLI at this point. I know, I mean, I get the preprocessor thing, but the other thing I had to like import in order to use like these certain things. So it's probably just my MLI being wrong. Let's just remove it. It's fine. I have it committed. So let's just remove it for now. Let's see, it's in lib hello world MLI. It's imported by mentioning it in the Dune file. Okay. Nice. So then we'll do just a Dune build. Okay. So then it's this part that is wrong, I guess. Well, first of all, let me exit this buffer so I don't get confused. And unbound value yo JSON of greeting. So I'm probably just using it wrong now. Okay, so then this just uses an at. So at deriving. Okay, now let's see how we actually use it. Okay. Page 2 yo JSON. Okay. Greeting of yo JSON of greeting. Let's see, what did we do? So this is just supposed to be greeting to yo JSON probably. All right. You gonna work for me? No, not today. To yo JSON. All right. And then so greeting to yo JSON, named of yo JSON. And what don't you like about this? Oh, okay, perfect. Yeah, so now I actually have results. How about it? I actually have results. Okay, so now named of yo JSON is giving me an error or. Okay. Let's see. What time is it? Oh yeah, it's kind of early. I'll probably be going at least another hour Scottish. That's a type alias for result. Thanks, Yawar. I was wondering about that. It's like, what? That's confusing. But they just wanted their own type alias. I guess we do that in Rust a lot. Like we'll do like my result so we don't have to like name our error 18 times. Like define all of our we'll just like new type something, you know? But yeah. Type alias. Okay. Okay, cool. So then we already have a result here. But that means that we can't just do a dot access. That means we actually need to map it. Okay, that makes sense. So do we have like a map operator? I don't think I've mapped something yet, have I? 9899 ISO. Thank you for the follow. I appreciate it. Here, let's get rid of this try syntax. That's just terrible. You can use result.map. Okay, that's right. That's right. I have to remember all of these the whole namespaced things. Okay, so result.map takes this. So what would be the nice way of doing this? I guess we could do is there a nice way to change dot access into a function, or do I just need to do like an anonymous function? You just have to do a lambda. Okay, yeah. I did those a few times, but I'm forgetting what I'm forgetting the, it's FN, isn't it? Is it just FN? Oh, it's fun. That's right. FN is SML and fun is OCaml. Because OCaml wants to be more fun. I get it. Fun n2 n.name. Okay. That looks okay, I think. Okay. And our type should still be string result. That looks good. The only thing is like this is doing the error or thing. Let me think about this. That's getting a result. What would happen, like what is this from string? What's this type? YoJSON.safe.t. I guess I should still get a what do you call it? An error, result.error here if from string was like invalid somehow. Okay. We'll just run it and see what happens. You could actually just pipe forward into result.map directly. Right. Okay. Yeah, that's true. That's a great point. Yeah, that would be nice. No points. We go even more point free on this. Yeah, that's a great point, Yower. And then we just have to get rid of our name here. Yeah, that's pretty sweet, isn't it? Not bad. Not bad at all. Okay. Okay, that looks good. Guess we'll just write it out. All right, let's see. Yay. Bad request. Okay, now let's... What if we just do this? That's what I was worried about. Blank input data. Dream.http error. YoJSON.json error. Blank input data. WTF. So YoJSON.safe from string still isn't giving me. Do they have like a similar thing here that would give me, let's look at this. That would give me a result back instead of just like raising. Can we do something like this? This is probably going to be huge. Not too bad. Read. I'm not seeing any sort of special results here. I guess that's just not a thing, at least in this particular package. Should I use a different package? Is there something else that's nicer to me about this? Or do I just have to literally go back to pretending I can catch this? This try with syntax. Okay. Finish string from sec from channel, line sec. Bunch of writes. To file, sec to string. Yeah, I'm just wondering. Okay, I'll show you. So this is working well when I have valid JSON, right? Now named with YoJSON has a result type, right? And so I can just map over that result, get my name, handle it in my handler like I already was. But the problem is if it fails here, this is not a result. And so I'm getting a runtime error like so. So that's the part that, so I was like, oh, maybe there's a function in yojson.safe. Really bad naming to say yojson.safe. You know, pretty bad naming. All right. I mean, I guess. No, I can't go back to the code. You should just know. You don't need to look at the code, Dylan. Just know what it is. What's not returning a result? yojson.safe.fromString. It just gives me this yojson.safe.t. But maybe yojson.safe.t does something for me? I don't know. Yojson dot safe dot t. Okay. How can I do anything with this? Type T. That's really helpful. I mean, of course I can add error handling other places. I'm just seeing if there's like an elegant way of doing this, right? Like I could check that the body is a blank string before I pipe it in here. But ideally, if I'm using a JSON thing, it just handles all of the problems for me. Why can was left over? Why can was left over? To YoJSON body, let star body to string body, and let JSON try okay. You do a try with, okay. Alright. Hate it. I mean, it's not the worst thing ever, but it kind of bothers me. So what's this let pipe about? Let pipe? Do I have that? No, I don't have that. Something special? Try okay. YoJSON.safe from string body. Oh, you define something yourself. Exactly, Les. Like, yeah, let's call this YoJSON.safe. Like, it's just funny because like usually like in Rust, for instance, right, we have like unsafe means that something like, and I don't mean unsafe Rust, but I just mean like you have your methods that like return results, and those are considered like the safe ones, and then you have the methods that panic, and that would be like what I would consider as unsafe. But you know, I'm not trying to hot take OCaml here. Exactly. No, Dylan can't bail out of his skill issues. Dang it. How did you have that many points, Badger? I should have made that more expensive. All right. That's only gonna work if you're an admin, and you're not. All right. That's hilarious. Okay. Now that makes sense, well typed. Yeah. That makes a lot of sense. Yeah, I wasn't like actually being serious. I hope you guys know I was just kind of memeing. But yeah, it makes sense. Yeah. Let's see. No, Dylan. Dylan can't bail meta out of his skill issues. I mean, can anyone actually bail me out of my skill issues? Cooldown is probably something like this. Oh, this should actually just be a channel points redeem, because you can't just use this and not have to pay for it. Oh well, I'll fix that later. Yeah, no mods. There's only one bestie mod. And what the heck, Justine? Where the hell are you? Stand up chair, exercise ball, good idea. All right. Let's see. Should we do ball Scottish, or should we do stand up? I'll let you choose since you redeemed it. I just have to switch to something. Okay, so where the hell were we? I don't think I care enough. I'm just thinking whether I care enough to do this. But I guess we'll see what this whole let pipe is. Okay. Bind, return BF. Okay. Yeah, I could see that. Moomy's are you missing Haskell right now, Moomy? I think Moomy's just missing Haskell. Dylan got a little ahead of himself. It's okay, he does that sometimes. But at least he has his own command. And now he has 2 commands on this stream. Oh my goodness. All right. Let's see. Should we do something about this? I mean, we probably don't need the whole bind thing, right? Because I could just have a little function that does what you were doing, but I don't need the bind because your function's doing more than mine. Because the bind is more about the... Yeah. I don't think I care about binding in this scenario. Because I can just take this, do a little try with, return a result. Okay. I guess we'll just do it real quick. Try JSON takes a S and it's going to say try yo JSON dot save dot from string S with, I don't remember the nice way to do this, with, I guess I should look back at your code in case there's like some stupid special, okay, I have to do the yo JSON.json error thing. All right, it's fine. With yo JSON.json error message, except I forgot the okay part. okay. We'll just do that. Pretend that's going to work. It's not going to work. You're not happy about that. Here to 0 arguments. Why are you applied to 0 arguments? Maybe that doesn't allow that in this construct. Okay, fine. We'll just be just like Dylan. Use parens. Fine. Okay. So then, yeah. So now we're gonna, oh, but then you have the whole stupid result. Friends make a friends. Friends. All right, Dylan. For not being a dad, you certainly got it. You certainly got the dad jokes down. One second. All right. Okay, so this is where my skill issues really show, in that I know there's a way I can take one result and then just like don't use this. That's funny. Okay. This just in, closure dev doesn't like parens. Yeah. No, I don't even see parens, man. You guys see parens? I don't see parens. Do I have any random closure snippets? Probably not. CLJ randoms. I think this is like just some unfinished thing that I was messing with. Oh, just like a dumb XML thing. I don't even see the parens. Do you see the parens? I don't. I was that bored that I just started writing an XML parser, and that lasted not very long. Okay. What was I doing? I already hate this. I already hate the fact that I'm doing this. Oh well. Because I feel like then I'm going to have to do something else, and, you know, like coding, and coding is hard. So we'll just do this. We'll pretend it's fine. Isn't body a string? Okay. Come on, Badger. You weren't here for Lisp week? Oh yeah, I forgot. I did a bunch of Lisps. I don't need to open up closure for parens. We've got parens everywhere. I don't want to open it up in Emacs because result.map named of YoJSON. Okay. And it will automatically well, there's still something wrong, right? We need a bind, right? Like that. YoJSON.safety to named PPX deriving YoJSON runtime data, but an expression was expected of type AB result. Maybe my function above is wrong. Oh, really? Oh, so then I can't use this. Oh yeah, okay, so let's look at bind. You're right, yeah, it's a result. Well, let's see. Let's see if I understand this. A result to a function. Right, yeah, that makes sense. Okay. Yeah, I get it now. I could do the let. I don't know. I think we'll do anonymous function because I think it's a little bit more expressive for where we're at as far as being a noob. I don't know. I said res just because you did. We'll call it J. We'll call it J. Okay. Cool. That looks fine. Thanks, guys. Okay, so this should still be giving me that, but now if I do a blank string, we should get a bad request. Ooh, how about it? Okay, and this bad request. Nice. Errors handled. Took longer than I thought it was going to. Classic. But I think it's looking pretty nice. You're welcome for all your help. You're welcome. Yeah, you're welcome too. I don't know why I said you're welcome. You're welcome for helping me. No, I know. You were extremely helpful, Badger. Okay. Okay, cool. So we did it. We did our 3 routes. We're getting proper error handling, and we finished our API. How about it? You're too short to have any real authority. I mean, isn't that kind of like a short person's thing though? Is that they have to like somehow claim authority somewhere? At least a short male, which you may or may not be. Short man's complex. Ford Raptor driver? Yeah, exactly. Hilarious. Nothing like the big trucks in Tennessee. Okay. OCaml. Error handling. Content type fixes. And more. Alright. Not bad. Okay, so let's do this. I need to... Oh, we have camel up? No, I need to have OCaml up. There we go. You guys can't see some of the things that we're doing here. But I'm adding this all to a group. And we say OCaml. And then can I copy all the links? No, I have to do it in bookmarks first. So then we're just going to do Command Shift F, Option Shift F. That's what I meant. And then we're gonna do Badger. Dude, that is really hitting the nail on the head right there. What happens if I just copy this and then put it into a plain text file? By this, I mean an entire bookmarks folder from Brave. Yes, that's what I was hoping for. Who needs a README when you just got a bunch of links? Okay. OCaml. Perfect. Let's delete that. PPXyo JSON conv. Screwing me over with your raised exceptions. All right. We don't need this one. All the rest of these are pretty good. I have no idea what this is. This is probably me. My random YouTube. We don't need that. ATS is not doing anything here. Let's delete Dylan's thing from our README. Nobody needs to read this stuff. Okay, there we go. Collection of links. Extremely good README for OCaml. OCaml. Excellent README documentation. Okay. Cool. Let's see. 136. Badger. WTH. Okay, cool. Let's see. There was something I wanted to get back into with the OCaml. Oh yeah, it's what we started with. And I know you're talking about this last night, Dill, but I actually think this is when I understood the whole sig struct thing. When I understood it 3 days in. No. I just found this to be like the easiest way to explain it, but maybe that doesn't make sense to new people. I don't know. Maybe it's just because my brain's just that big that this is just all I needed to read and I understood the MLI and the ML thing. But that just makes sense to me. I mean, maybe without any context, it really doesn't make sense, right? Okay, so let's look at this. What can we do? Let's just define. Didn't I define a like little module or something? No. Okay, we'll just define one real quick. Make sure I remember how to do it. We'll go at the top. So we'll define a module manually. And we'll say meta mod. It's really good. And we can just say it's a struct and it has a type S, which equals string for no reason. And then it has our own concat just for the hell of it, which takes a XY and does X caret Y. Okay. And this looks fine. And then we just say n double colon. Okay. So now if we say show metamod, I wish it would format it differently, but that's okay. So we have struct type S equals string. We have a function that defines concat, and now we have sig. Our signature for our module is type S equals string val concat S to S to S, and that's our whole signature. So that's the same thing as if I was in an ML and MLI file. Oh, that's funny. I did start this. Okay, so if I was in an ML and MLI file, let's actually just move this real quick. I called it my mod. We're going to call it meta mod because it's obviously better. And we defined this here. So we would say whoops, I wasn't in insert mode. Classic me. Type S equals string. Sorry about the semicolons there. Habit from Rust, I guess? I don't know. I just type wrong things all the time now, and I just say it's a habit. Right, I actually have to have a let. Okay. So I've defined a type S. That's just a string, right? Just type alias, basically. And then I've defined a function concat because I don't like infix operators. That's not true, but we'll just pretend I don't. And then it's here. Okay. So then in my MLI file, which I don't have yet, we could just take this exactly like it said here. And what's pretty cool about this, which I didn't even think about, I split it at the wrong point. Classic me. I didn't see this at first in the REPL, but it already inferred that even though this was like a string, it used my type alias. It's pretty sick, right? That's pretty cool. So the whole point of this thing down here, let's see, where was it? No. Where was that extremely good explanation? Let's search for MLI. There it is. Under modules and separate compilation. It was at the very bottom. Yeah, it'll go, yeah, no. That could be annoying too, but it's still kind of cool that it even tries to do it, even though it can be annoying. So the point is that module A sig contents of a.mli equals struct contents of file a.ml. And so here, module metamod equals struct type this and sig type s. So this is the same thing, what it's showing here. Module metamod s, and then it gives the whole signature. And I could actually define this differently. I don't know if it's going to let me since it's already there. But let's just say I wanted to say sig type s equals string val concat s end, and then equals struct type s equals string let concat xy equals x caret y, and so that's all it's saying. Now I got an error, but that's fine. But that's just because of a typo. That's not too surprising, is it? I don't know how to go up a line. Is there a way to go up a line? There we go. Now it worked. And it let me do it. So this is just like a manual way of doing it, like to understand what the module, the struct and the sig is for a module. That's all. Why does that matter? I think it gets more interesting when you start actually using these modules, like the higher order modules in Functors, is where it actually comes into play. So we could define something new and say we wanted to say, let's define a new type. Again, this is not exactly the most helpful thing, but let's say we want our S's to be M's. So we could say module type metamod M equals sig, and we could say type M equals string. Oh wait, oh, that's not gonna work, is it? Let's see. We'll say type S equals string. Type M equals S. And then we could say val concat equals M to M to M. End. I got a syntax error. What did I do wrong? Module type metamod equals sig type s type m equals s end. I don't know why it's wrong. Interesting. Anyone else have an idea? Why am I wrong? Not equals? Oh. Oh yeah, val concat is a colon. Ah. Nice one. Good catch. Badger. Good job. Okay. So then we could say this. And it's currently not used anywhere, right? Like if we do a show metamod, we still have our original signature. But if we wanted a new module, we could, let's do this real quick. Let's see if we can do this. Can we say module metamod m? Oh yeah, let's try this. Metamod let's try this. I don't know if this is gonna work. If I can just like new type this module, basically. Equals metamod. It doesn't work. That's okay. How do I use the new type that I just described? So module type FIFO equals sig. Module abstract q equal, oh, there it is. Okay, I just had it wrong. So I'd say module metamod 1 equals metamod m, whoops, nope, metamod, that's my original thing, with metamod m. Obviously the naming isn't helping anybody. Really? That doesn't work? The type m is required but not provided. Okay. That's fine. We could say module metamod 1 metamod m, and I think this will work, equals, and then we have the include syntax, struct include, oh yeah, because we never defined, that's why, we never defined type m in our struct. That's why it's not working. So we could say include metamod, and then we could say type m equals s, and let's see if that works, even though we don't have s defined here, and it does. Okay, so now if we say show metamod 1, okay, not what I was expecting. I was expecting to get the whole sig. The way the other one did it. Interesting. So then if I say show metamod m, okay, so we extended that module with a new type and we're using it, and we should be able to actually use it. Like we should be able to say concat hey you, and it works. And the point is that concat, what is it, hash type of, okay, oh right, I forgot, you have to do this in strings. Okay, yeah, it's m to m to m. Like, is that like mind-blowing, probably not, but because it's not like it shows a whole lot, like if you can't think of how you would use it. But I think it's pretty cool to be able to extend modules, add some new things, play with different types. The thing we did before, the deadly hump. Yeah, the thing we did before is we could hide types if we wanted to, right? So if we wanted to, we could have, let's see, what was it? Our sig. We could define a new sig. And I think that was, what is it, module type? I think that was it. If I wanted to define the new sig, I'm forgetting. Let's click. Module type, yeah. So we could say module type. Let's use the original metamod. And say we didn't want to show what S was. I think we should be able to do this. And we should be able to say sig type S type type M equals S, and then val concat M to M to N. And end. Let's see if this works. Yep, that works. Okay, so now compared to our original MLI, like we have here, oh, nah, it's probably not actually working the way that I did it, but it's fine. The point is that you could hide the actual internal implementation of this type. I did it with my Hello World MLI yesterday, but yeah, I'm liking OCaml. I think it's pretty good. It's different for sure. I think the module system is probably one of the more interesting things coming from Haskell. I mean, of course, we don't have type classes. Some people think that's a good thing. But I do miss type classes a little bit. Makes the syntax a little bit simpler. I know there's some talk of getting type classes, but that's okay. So we could go into functors, but I think I'm kind of done for now. I think this is good. I really like this article, by the way. I think maybe if you're like super beginner, it's probably not that helpful of an article, but I actually think this is a great explanation of how functors work and some of the power with the OCaml module system, which I did a very poor job of probably demonstrating. But you know, I also haven't really used the language that much, so like I didn't have like a great practical example in mind. So we're just kind of playing with like how we could define the type of modules separately from the modules themselves, the implementation, right? So anyway, thanks so much for hanging out. We finished our web API in OCaml, which I think is pretty cool. We have a list of links that you can check out if you really want to. And yeah, it doesn't sound too exciting, but it allows for smart constructors where you can guarantee that something can only be of a type if it passes the constructor function. Yeah, like an email or some kind of important value, like a monetary value. Yeah, totally. No, that's a really good example, right? It's what I showed at the end of my last stream, which was basically if we define something, if we hide it that way, the whole type S thing, where we're hiding the actual type of S, it means that anyone outside of this module isn't going to be able to actually construct a type S. And that's really important, right? Because then if you have a, like what Les is saying, like if this was type email, right? So you had like a module type email equals, it's like a new type with a hidden constructor in Haskell. Yeah, that makes sense. So yeah, you had like module type email, and technically, right, type email is probably just a string. I guess we call it's lowercase, isn't it? I always forget. And then, you know, if you had a function in there, that was like S to email, then the problem is if you left your type like that, let's not worry about the syntax error because it doesn't matter. If you left your type like that, right, somebody in another module could just be like, oh yeah, type like email.email equals this, you know, and I can just like basically construct it. It's probably not a completely correct example, but I think you guys know what I'm talking about, right? It's correct enough. So I think that's a great point, Les. It's like you can hide that internal implementation to make sure that somebody doesn't bypass your constructors, right? Yeah, I think that's awesome. So it's really powerful. I wish I had like this really, I don't really have time to do it anyway right now, but I wish I had this like really great example of how we could use a functor to do something cool. But I actually like the FIFO example, their little queue example here. I think they do a great job of showing like, well, the FIFO, it doesn't apply here. But basically they create a set functor that takes an ordered type, and they only have to define this functor one time. And then of course your ordered type is, did they do it up here? Yeah. Let's see if we can just look at it real quick, because it is really cool. Here we go. Module type, ordered type, right? So they define a type T. Again, here you go. They're hiding what that, like this type T is, well, this type T is actually not defined because it's generic, right? And then it's val compare TT comparison, right? So there's your signature. So any type that is going to define that type T, and they just have to define a compare function, you can then pass into this set functor, and you get all of these things with it. So it's using, so ELT is the type you're passing to it, and it's just using type element equals ELT.T. You can match that ELT compare, and then you suddenly have this powerful set that you can create different things. Like an ordered string, here they are defining an ordered string is that ordered type here, right? That might not have made sense to anybody, but if you go through this and put it in the REPL especially, I think it'll make a lot more sense to you. And I think it's a very cool pattern, and it's something that I like. This is kind of like, if you want, I mean, regardless of what they're going to do with OCaml in the future, right now, what we can do with it, like if you want a certain way to abstract something the way you would probably do a type class in Haskell, you probably, you know, it's not one-to-one, but you could consider using a functor in OCaml. That's the way I would say it anyway. It's not like perfect, but it's similar to that. Like the way in which you would put those pieces together is different, but it has that same level of power as a type class in Haskell or a trait in Rust. But the way that the type system interacts with it and everything is different. And some people think it's better. I don't have an opinion on that at this point because I haven't used it enough. I'm used to type classes and traits and I love them, but yeah. Yeah, it's not quite as powerful though. Yeah, it's fair. It's fair. I mean, the fact that in Rust I can just do, I mean, you know, compiling SQLite binary. I don't remember asking for SQLite Emacs, but thanks. The fact in Rust that I can just import a trait such as an index mute, and then use special syntax like this is a custom type in Rust. It's a ring buffer I implemented, and then I can just use index access syntax is just like, and that's not even like the coolest thing, right? But it's still just like, wow, I can just impl this and I get all these special, like I can feel like I'm a real boy, like my type is real. So it's pretty awesome how you can use traits. And obviously there's a lot more to it than that. Iterators, all those kinds of things. You know, it's like you impl iterator for your ring buffer, and then suddenly so much is opened up to you. So many different libraries you can use. So much interface is opened up to you. So, you know, again, traits are awesome. Functors are cool too. How about that for a thrilling conclusion? Traits are awesome. Functors are cool too. Scottish, I never actually changed. I just stayed in my chair because you were supposed to tell me what I was supposed to switch to, and I never did. Anyway, thank you so much for hanging out. We are going to start on dependently typed on Saturday. We're going to start with cock. Then we're going to go into IGDA. Wow. Little portmanteau between Agda and Idris. We're going to start with cock, go to Agda, and then do some Idris. That's all going to be coming up this week before Wednesday, most likely. So Saturday, Sunday, Monday, Tuesday should be thrilling, assuming that my schedule ends up working out for all of those. So if you don't already follow, send me a follow, and you can catch some of those ridiculous things that we do. I don't know everything, but we just kind of explore, and we learn by exploring. And we get cool people on chat that know a lot more than I do about all these languages to tell me why I'm wrong and what we should do differently. So that's kind of the deal. If you want to hang out on Discord, I finally updated the link. I hang out on Dylan's Discord. We co-parent it. There's that. If you want stream notice and stuff, they're in Discord. If you don't want to join the Discord, you can follow me on Twitter. And if you want to catch like the beginning VODs, they're all on Twitch. But if you prefer YouTube's interface, there's the YouTube. So let's see. Who should we raid? Doesn't look like there's that many people streaming right now. Just did that. I guess I don't know if I've ever. I could raid trash. I've never raided trash before. I don't know if I want to. Yeah, Les, thanks for hanging out. I really appreciate it. Let's see. Anybody doing OCaml? Probably not. That would be just me. Anybody doing Haskell? Probably not. Nope. All right. Good deal. I guess we'll just raid this trash guy. We'll see what happens. Speen, thanks for the follow. I've seen you a few times. I didn't know you didn't follow, man. No, just kidding. Okay. Raid trash dev. All right. We'll see how this is. You should. I mean, I've watched Trash before. He's funny. I mean, like he's a little crazy. Netflix, by the way, for sure. So he's got that whole thing going on. Oh, I still don't have Brave muted. Wow, who knows what I was putting out here. So yeah, thanks again. Thanks for watching, and we'll catch you all soon.